So today we discuss dipole. Okay. Previous class we discussed what is electric field and concept behind the electric field. That's very important. Now we continue the previous topic. What is dipole? Okay. So dipole. The dipole name suggests there is a two pole. Okay. So one is north pole, another is south pole. Like so, one is positive, another is negative. Two opposite charges, unlike charges. Okay. So that means the two pair of equal charges, equal and opposite charges. If one is a plus q, another is a minus q, and they are separated by some distance r, or say the 2r. Okay. So dipole means there is a pair of charges, means a plus q and another charge is minus q. Both the magnitude are the same, but there one is positive charge and another is a negative charge. The polarity different. Okay. And here separated by some distance, say some distance is called 2r. Why you choose the 2r not r? They are as important. Okay. Why choose the 2r not r? If you choose the r, they are also correct. Okay. So in between a midpoint, that's important. Okay. That point means in between these two charges, the midpoint is r and other is the r. Okay. So we get the another is called dipole moment vectors. Okay. So what is dipole moment? So dipole moment. Okay. And in class 10 physics, we know that in ICSE 10 first chapter, what is the moment of force and what is torque is a rotating vector. So here the dipole also introduced for rotation. Okay. So when the dipole moment vector P from negative to positive, negative charge to positive charge. So what is dipole? If someone says that an electric dipole, what is dipole? And electric dipole is a pair of is a pair of equal and opposite charges. Equal and equal means equal magnitude and opposite polarity. Opposite charges. Opposite means pole. Okay. Polarity charges. If you like the one plus q, another is the minus q. We say that that is a 10 plus q and a 10 minus 10 q. Separated by a distance and separated by some distance. Okay. The total charge of the dipole is 0. Okay. If one is a total charge, if someone calculates total charge with plus 10q and minus 10q, plus 10 and minus 10, we get 0 coulomb. The total charge of the dipole is 0. Okay. Total charge is 0. Charge is 0. But electric field is not 0. What? E not equal to 0. Okay. So we get a dipole moment a vector. How to calculate a dipole moment vector? So P defined as the P, that is Q, or anyone either plus Q minus Q, that is the magnitude of the Q. Okay. So ignore the plus minus, and the cross product is a moment vector. Separation is 2R. If someone separates that separation is R, A, both are the same. Okay, nothing different. And the direction is P unit vector. Okay, that's the dipole moment vector. Important. is defined as P. If someone says the difference between these two is say that is the A, that is also that is equal to P vector that is equal to Q times A, and that is a P cap. They also true. Okay. And more what is that is dipole. Okay, now we can calculate electric field when dipole plays in electric field. Okay, when a field and electric dipole when for the point on the axis. Calculate electric field. Now calculate, very important in board exam. Okay, the derivation is very important for board exam. The field of an electric dipole, the field of an electric dipole for the point on the axis. First we discuss for the point on the axis. Okay, so consider that is a two charges, obviously, because we say that the dipole has the two charges. They are same in magnitude but in opposite polarity. That is a okay. So dipoles means that is a one is plus Q and another is that a minus Q. Okay, that is a plus Q, that is a minus Q. Okay, separated some distance, say that is say that distance is 2a. 2a, and in between the point, middle point of the dipoles, so p vector of minus to plus direction. Okay, now calculate electric field of an electric dipole and EP at any point P. Calculate at point P electric field at point P for given dipole. So we say that is a P always measure the outside point of dipole from center point of the dipole. Okay, measure starting from center point of the dipole to ending point is which point do you want to choose to calculate electric field. Okay, so P that is okay. So from P to dipole center distance, say that is a R. This is R. So electric field at point P we want to calculate. Okay, there's a dipole axis. Okay, that is a dipole axis. Or say that is the x-axis of that dipole. Okay, that is a x-axis. Okay, how to calculate EP? Very easy. So first, point P, sorry, it's a plus Q. Okay, okay, plus Q. Electric field at point P due to plus Q charge. We know that electric field starting from plus and ending toward minus. So electric field in that direction. Okay, so we know that. So that clear the diagram. Okay, neat and clean diagram. So electric field at point P due to plus Q charge is away from, sorry, not P, that is name is plus Q. Okay, due to that is a Q is positive, so that's why the away. Okay, plus 2 towards some distance we get a minus charge, 2 to plus 2 minus. So electrically in that direction, and here's a minus, and electric field at point P due to or with respect to minus Q is towards. So electric field starting from positive and ending to negative. So that's why E minus in that case towards negative. Okay. So now we can calculate these two at point P. So total E at point P. Okay. So we get a E of plus E of minus. Okay. So very easy. So E of plus, you know that from electric field definition, K, Q, and electric field doesn't depend on test charges. Okay, so that's very important. Test charge. If you want to calculate at any point has the field present or not, then bring a test charge. Either positive or negative, bring a test charge. If I say the test charge is positive, so there's outside or inside. Okay, towards. So first bring a test charge, and very important point is electric field doesn't depend on test charge. Okay, it's independent of test charge. So that way if you choose a positive negative, it doesn't affect that equation. Okay, so K, and that is a plus Q. I know that plus minus ignore here, that is a modulus value plus Q. So that's why ignore the plus minus term. Q by their separation from plus E plus. Okay, E plus, that electric field due to respect to plus Q. So that distance actually E plus we get in that distance. So there. And that is a 2A from, we know that dipole center, that is equally two parts divided, that is A, and another is also that A. So if that is dipole center to that point P, that is R, if that distance is that distance. Okay, actually that distance is from here to there, that is R minus A, that is R minus A. So that's R minus A whole square, and that is the displacement vector in also parallel to point parallel to P, dipole moment vector. So that is the P cap direction, same direction, dipole moment vector, and so electric E plus, both are in the same direction. That's why P. And another plus E minus, so K Q modulus value by R square. For at the point P, E minus with respect to minus Q. So the distance is from here to that goes up to there. So we know that is a point P to point D, dipole center get R, and extra is A. So that distance is R plus A. So that is R plus A square, and E minus towards point P. So P and P dipole moment vector and E minus both are in opposite direction. That's why the minus P cap. So now we can calculate these two. So we get a K Q common 1 by R minus A whole square minus plus minus 1 by R plus A whole square. P unit vector direction. Okay. Now that is going to KQ, solve this. So R minus A or R plus A, R minus A whole square times R plus A. That's we get. So R minus A whole square, so here you get R plus A whole square minus R plus A, so R minus A whole square. That is a P cap. So that is again some KQ, that is A plus B whole square, R square plus A square plus 2RA minus R square plus 2RA plus minus minus a square. So r square a square cancel here by r square minus a square whole square. This whole square a minus b a plus b a square minus b square. That is a p cap. So get kq 4ar by r square minus a square whole square p unit vector. So now we put k means 1 over 4 pi epsilon naught 4 a q r by r square minus a square whole square p cap. Okay, so now we apply some boundary condition. Okay, say that I'm applying boundary condition and we get, so boundary condition is that is r is much greater than a. So that means 1 over 4 pi epsilon naught. Okay, so 4 a q r. So r much greater than a. So means a is ignored here. Okay, so here is the r square and here is r2, that is r to the power 4 and p cap. So that is equal to 1 over 4 pi epsilon naught 4 a q r by r to the power 4. Now cancel r cube p cap. Okay. So if we put 1 over 4 pi epsilon naught some 2 a q, that is the p unit vector by r cube. Okay. So what is 2 a q p unit vectors? Direction. Okay. That's very important because a dipole moment vector p equal to 2 r means this forms a midpoint of dipole to any charge, okay, towards r. So if that direction, so cross product, what is this represent the cross product? If a cross b, get ab sin theta, theta is the angle between a and b. Okay, okay, a and b. So what is the force actually? If that is a rotation, okay, if that is there is a rotation, so in class 10 physics, first chapter, if we put a seesaw bar, that is a fulcrum point, and one boy sit here, another boy sit here. If the one force is downward direction, now another force is the upward direction. So angle actually this between two displacement vector and force, that is equal to 90 degree. If one charge is negative, that is f of minus q, and here other charge is positive, f of plus q. The separation r, that distance, and that distance also, say that is r. Okay, so we get, so put actually here the p equal to, suppose say that 2a distance times q sine 90 degree. Sine 90 means 1, so 2aq p unit vector. Actually the direction is very important. So 2aq here represent a cross b product. Here that is ab sin theta, means sin 90 only get ab, a times b. So here we get, so 1 over 4 pi epsilon naught 2 p vector or r cube, that is E at point P. Okay, that is very important here. Okay, that is Very important. Okay. So we can calculate electric field at point P due to electric dipoles. Okay, dipole axis. Now here important factor is here we apply the boundary condition, that is R is much greater than A in that case. Okay. Next we will calculate for the point on equatorial plane. That's very important point. The equatorial plane. Now calculate same calculate electric field. Let EP for points on the equatorial plane. The P point, actually the point P lies on the plane. Okay. So first we try to draw a diagram. Very easy. Okay. Skip that for you space. Okay, that is very small. So we need a clean diagram. So means the dipole means that is a two charges and plus q equal and opposite polarity, that is a minus q. The separation is same. The separation is here say that is 2a, that is a dipole center. Okay, so P in that direction from minus to plus. So here the plane. So equatorial plane means a plane bisect. Okay, these dipole actually bisect this dipole, this plane, and actually point P lies here. Point P. Okay, so that distance is A. That distance also A. Okay, now at electric field at point P. Calculate electric field at point P. Calculate E P. Okay, equatorial plane. Point P is a lies on the equatorial plane. So we now join these two point. Okay. Now these distances are. So from here to these distances are. Okay. So electric field at point P due to plus Q charge. So that is positive. So away that is E of plus, and that is a minus Q due to minus Q at point P electric field. That is a minus means towards in that direction. That is E of minus. Okay, so that is if I added these two, so vectorically, so you get electric field at P here. If this angle is theta, so this angle also we say that theta. Okay, and this angle also be the theta. Okay, now I try to calculate that EP. So if that is vertically added, so EP we get E of plus, E of minus. So what is the value of E of plus? First we consider a magnitude. Okay, first for solving that equation, first we granted there's a E magnitude only, and we get E plus. we know the definition of electric field is K Q by R square. So R, so separation square means this line, that is A and that is R actually, that is A and that is R, and that is a right angle triangle, that is a right angle triangle, that is a base and hypotenuse. We apply the Pythagoras theorem, so we get a base square plus perpendicular square root over of these, we get hypotenuse. So A square plus R square root and the whole square, we only magnitude, that's why we ignore the direction here, and E minus same K Q by R square, this is the equilateral triangle, so that is A and that is R. From apply Pythagoras theorem we get that is the hypotenuse equal to root over of A square plus R square, so root over of A square plus R square whole square. So the root and square will cancel and we get K Q by A square plus R square, same K Q by A square plus R square. So if I added these two, just added, we added these two. So 2KQ by A square plus R square, that is the EP. And now another important is that a direction here. Okay, now if EP, see that is EP and E plus not in the same direction. Okay, and E plus and has EP. If you want to calculate added these two, E plus and E minus, so that is important. They must be lies on EP, or they must be parallel to E plus and E minus must be parallel to EP. That's important. Parallel, but must be lies on same line. Now that's why we convert these two. So that is E plus and that is angle theta, and we know that the E plus component, that's component, this is that is called X component, and if I say it is a Y component, that is the X component of, say that is X and that is a Y. So E plus on X component is, so we get a 2KQ by A square plus R square, and that is okay, not equal to here. Now that is only EP magnitude. Okay, so you see that if E plus and E minus both are not in same line, so that's why E plus on EP. Okay, so X component of E plus, that is we know that is E plus cos theta, and similarly also the E minus X component of E minus vector, that is also equal to E minus cos theta, both in same direction, E plus P direction. Okay, so we get actually E P, so E plus cos theta and E minus cos theta, both in, see that they are not in same direction of P momentum vector, not in, sorry, P vector, dipole moment vector. Okay, that is a P dipole moment vector, not in the same line here. Okay, so dipole moment vector actually left to right, negative charge to positive charge, and EP, that is a to right to positive charge to negative charge actually. So there is 180-degree difference, both are in opposite direction. So that's why minus E cap very important. So if I E plus and E minus, we get the same value and cos theta be the common. So E plus E minus some cos theta, and we get a minus a P cap only. So we get E plus and E minus, if we add it, these two we get here 2KQ minus 2KQ over A square plus R square cos theta p cap. And if I calculate another way, solve these two. Okay, so another way like this, so vectorically algebra, the method 2. So E plus in that direction actually, and EP in that direction. Okay, and E minus in that direction. So if I draw a parallel line to E plus, sorry, actually E plus to EP in that direction, that is a E plus, E minus, and EP in that direction. So if we apply the vector triangle law, so E plus P positive, clockwise be the positive, anti-clockwise be the negative. So that is minus of E plus anti-clockwise minus of E minus, that is equal to 0. Okay. So finally we get a EP that is equal to E plus or plus E minus. And if you consider the both direction be the same, say that cos theta. Okay. So let's clear. Now what is the value of cos theta? So see the diagram first. So P, some say that is small Q and say that is a center point of dipole. That is a right angle triangle at cos theta, the base by hypotenuse. You know that trigonometric ratio. So cos theta equal to base by hypotenuse, that is A by root over of A square plus R square. Now replace that cos theta. So minus 2 KQ by A square plus R square A square plus R square, and cos theta be the base over hypotenuse root over of A square plus R square and P cap. Now put the minus 2k, minus 2k means 4 pi epsilon naught. So a q, that is a q, and if I added these two, so actually root means to the power half. So a square plus r square, and here the root is a square plus r square to the power half, and that is a p cap direction. We get that, and that is minus 2aq p cap, that is 4 pi epsilon naught, exponent formula, that is 1 plus half. So a square plus r square, 1 plus half means 3 by 2. Okay. Now we apply boundary condition. Before boundary condition, that is the final value, that is a EP, that is equal to minus 2aq by 4 pi epsilon naught a square plus r square whole to the power 3 by 2, and that is p cap. That is a final value before boundary condition applied. Now we apply the boundary condition, applying boundary condition here. So boundary condition is that if that distance actually, okay, so means the r is much greater than it. This distance point is much higher than dipole center. Uh, so r is much greater than a, so we get, so EP minus 2aq over 4 pi epsilon naught. So ignore that a square, so we get r square times 3 by 2 to cancel, p cap the direction. So we get final EP, that is equal to minus What is the value of 2a q and p cap? Okay, so we get that value here. So that is a dipole moment vector, the dipole moment. So that is equal to 2aq. Okay, so that is a p vector dipole moment over 4 pi epsilon naught times r cube, and that is the final answer after applying the boundary condition where r is much greater than a for the equatorial plane, the dipole moment. Okay. So here see that some condition. If dipole field is large distance, if dipole field is large distance, the false is not 1 by r square, actually gets 1 by r cube. If r is much larger, let's see that is EP k some p 1 over r cube. Okay, if distance is suppose that is much higher, suppose the 2, or suppose that 2 meter, say 2 meter cube, that is 8. Okay, 1 by 8 times. Okay, so electric field is 1 by 8 times lesser than that. Okay, previous one. Let's say that is okay. So that distance is inversely proportional. If r is increasing, much increasing, that is cube root cube r cube to the power 3. That's the relation. So the magnitude of the direction dipole field is depend only the distance r, but also the angle is positive vector of p. Okay. So if that is that, sorry, not only positive vector p, say that is that if p is from minus to plus and p that is plus to minus, opposite direction actually, and dipole moment vector. Okay, if you actually say that, if some say that if distance is 0, okay, that distance be the 0, so distance 0 means 0 into something gets 0, and that is something that we get at the infinite. Dipole moment vector is infinite. Such dipole is called a point dipole. Okay, so the dipole field, actually the dipole field, note that the important note, the dipole field, the large distance falls, the large distance falls of not 1 over r square is 1 over r cube. The magnitude and the direction of dipole field, the and direction of dipole field depend not only the distance, depend not only the distance, okay, but also depend angle between these two, also depend, angle between R and P. Okay. Angle between R and P. Very important. R and P also depend on, see that R and P, that is RP is 90 degree. So you get a 90 minus sin 90, 1 sin 0, 0. If 2 say that is R and P, if say that thing that between dipole sides 2A approaches to 0, if say someone say that is 2A tends to 0, okay, between two charge, distance between two charge, dipole charges, it will be 0. So that one q charge approaches to infinity. So q is to infinity in such a in that if p, that is q times 2a, that is also is equal to finite number. Get it? A finite number. Okay. And such dipole is referred to point dipole. Okay. This dipole onto a 0 is called point dipole, because the distance between two charges is 0. So that dipole is called point dipole. That's important. What is point dipole? Okay, actually, point dipole, and that is the exact for any value of r. That is not a depend any value of r. Actually, r doesn't depend on r electric. Okay. So next class we discuss what is the physical significance of dipole, and when dipole placed on electric field, what will happen. These two points and solving some numerical. Okay. So today end the class here. Thank you.